Some more examples for simplifying square roots. So a, square root of 32. Let's bring it down, that way we have enough space. So 32. Now let's write the prime factorization. 2 multiple to give us is 32. Well, it's a multiple of 2, or it's an even number. So 2 times, what's half of 32? Half of 3, closest thing is 1. Half of 12, that's what remains. Half of 12 would be 6, so it would be 16. 2 times 16 will give us 32, right? And now 16 is not a prime number, so let's break it up into prime numbers. 2 times 8 will give us 16. 8 is not a prime number, so 2 times 4 will give us 8. 4 is not a prime number, so 2 times 2 will give us 8. And let's finally make a final list. There's my final list. There's 1, 2, 3, 4, 5 2's. If I multiply all of them together, I should get 32 again. Double check. Make sure our answer is correct. So 1, 2, 3, 4, 5 should give us 32. It does. That works. Okay, let's circle pairs of numbers. There's a pair of 2's there, and there's a pair of 2's there. This will make it a little bit easier to see. I could have circled the pair in the middle as well. Be aware of that. So now let's rewrite this square root of 32 into pairs. There's a 2 quantity square, or caret, or an exponent of 2. That way it represents a pair of 2's. And we have 2 pairs of 2, so I have 2 squared times 2 squared. There's one in the middle that does not have a square because there is no pair. So that would be the one I wrote at the end, up at the top. And now let's separate them into individual radicands. So individual radicands, one radicand or square root for each. Let's realize that the square root and the squares are opposite, so they cancel each other out. There we go. That leaves us with 2 times the square root of 2. And the square root of 2 is only going to give us an irrational number or a continuous decimal number. We want to leave it as an exact value. So we have 2 times 2 gives us 4. And let's remember, we need a plus or minus always whenever it's a square root. So let's circle our solution, and that'll be it. So any even number root needs a plus or minus. So specifically even more when it's a square root, right? Let's go for the next one. B. Square root of 60a squared times b squared. Let's bring down to 60. And let's write the prime factorization once again. I won't make it as long this time. So let's realize that it ends in a 0, so it's a multiple of 10. So you could go 6 times 10. Multiples will give us 6, 2 times 3, and 2 times 5 will give us 10. Agreed? So there it is. And there is technically a prime factorization. I'll rewrite it, that way it's in order, smallest to biggest. And I'll notice that there's a pair of 2's. There it is. I circled the pair of 2's. So that one we can convert it into a 2 square. So let's do that up at the top. And let's rewrite it. It now became 2 squared times 3 times 5, because they don't have a pair, times a squared times b squared. Now let's separate each individual radicands. 1 square root for each of those numbers or variables. There we go. And let's realize we can cancel square roots with the squares. So square roots cancel the squares. There we go. We cancel 3 of them. That means the 3 and the 5, we cannot cancel them out. But the 2, the a, and the v, we can bring them to the front. So there it is. 2 times a times v. The 3 times the 5, we can write in a single radicand because they weren't able to get out of the radicand or the square root. So there we go. Inside the radicand or square root 3 times 5. And 3 times 5, let's simplify that. Why keep it as a multiplication? Gives us 15. So we have plus or minus, right? Because it's a radicand, it's a square root. So plus or minus 2a times v times the square root of 15 would be our final answer. There it is. Let's go for the last one. See, we have 4 square root of 23 x squared times the y. Notice the 4 is outside of the radicand already, outside of the square root. So it does not get affected. Be aware of that. If it's outside of your square root, it does not get affected by the square root then. But the 23 is inside the radicand, inside the square root. Is there a multiple that gives us 23? I believe 23 is the prime number, right? So in that case, let's break it up into individual radicands. To help us visualize this, square root of 23, we cannot do it. Does not give us an exact number. So therefore, we're going to leave it as an exact number for now, square root of 23. But let's realize the x has a square on it, and the square root and the square cancel each other out. So that leaves us with just the x. So let's bring it to the front. We have 4 times x times 23y. And that's inside the radicand square root, right? So that would be technically our final answer. We can't simplify any further. So plus or minus 4x times the square root of 23y.